The example was tangent planes. Find the equation of a tangent plane to the following surface at given u and v. First of all, remember what u and v are. Those are like very random choices. Not very random, but any kind of choice how to parameterize this shape. So you can imagine this kind of game when u helps u and v, helps you to describe what you see. This u and v can be chosen by u. So if it's polar, maybe theta and r. If it's rectangular, something the x and y. So this one we had theta and z. So let's see. In this case, they gave us u and v. We did not have this before. And you immediately stuck. When you stuck, you just try to remember keywords. And what do you remember? Equation of a tangent line usually starts with differentiating. Don't just differentiate the function you have. That's what we did. This will be partial derivatives. We found partial derivatives and plugged in the point. Now, they ask us to find the plane. That takes us to the very good review of for the final exam. To find equation of the plane, remember you need a point and a normal vector. So a point does not fix the exact plane, but a normal vector sticking out like this fixes a unique plane. So that's what we need now. But also recall r sub v and r sub u, they lie on the tangent plane. They are on the tangent plane. That makes sense because those are derivatives, partial derivatives, but those are vectors which we got from differentiation, so they are on the tangent plane. They can give us normal vector. How? Who remembers? Cross product. Good job. So you see, people remember something. That is good. So we need a normal vector. Let's find a normal vector. And the normal vector is perpendicular to both. That is, let's call it n, which can be found by a cross product of r v cross product r u. That reminds us that it looks like so. Here's a more beautiful picture. N r v times r u, like so. At the given point 1 and 2, that was my u, it was given, and v was given as 1 and 2. So this is a nice review for the final exam. How to find a normal vector. N is ru times rv, which is, we have both, so it's going to be 2, 0, 1. Cross product 0, 4, and 1. And now we remember it's I, J, K, put in order and start multiplying. Start multiplying. I times 0 minus 4. I can see it from crossing. Minus J times 2 minus 1 plus K times 8 minus 0. That gives me minus 4i minus 2j plus 8k, which is minus 4 minus 2 and 8. That is my normal vector. We found it from cross product of two tangent vectors. So we need two things. We needed two things. We needed n vector. Normal is found, but we don't have a point yet. Actually, point is missing. So point. Step 3. Step 3. We also need a point to fix the plane. Well, we are given 1 and 2, so let's just plug it in. When you plug it into original, remember it's exactly what we did, the equation of a tangent line. Derivative, and now you plug in to find the point. So just the cross product is different, but here you plug in the point to find the point, the given point on the tangent line. In this case, tangent plane 2, 5, and 3. Finally, building the equation of the plane. And this is the one that I think you guys completely confused. I gave you so many equations, and I totally understand that you're probably getting confused with all of them, or some of them, I don't know. But maybe I should remind you, if n. Let's do it like so. Let's call it n1, n2, n3. So it's going to be n1 multiplied by x minus a plus n2 x minus b plus n3 x minus c. I just created this notation right away on the flow, where n is the normal vector, n1, n2, n3. That is basically our slope, but instead of the slope as a derivative, we're using normal vector. And a, b, and c are coming from the point a, b, c. I just made up this notation, but that's the beauty of it. You just need to know the idea behind it. Instead of memorizing the formula, different countries use different notations, so that is not fixed. So let's build it. N is found. There was a check mark over there. Here's a check mark point. Minus 4 x minus a shift. The shift is r. It's a point. Minus 2. Minus 2 x minus shift. That's a 5. And 8 x minus 3. Not x though. That's the mistake. Did you catch the mistake? 3 variables should have 3 variables. Y and z. Y and z. X, y, z. Yeah, fix that. As you can see, we don't need to have unit normal vector, so just normal vector is good. And that is the answer. Put it in the box. That is the answer. This requires understanding lots of materials. We are given some parametrization at first. The parametrization was given. Again, for you to understand, parametrization is just one of the ways to name or describe a surface. So instead of saying, find the tangent plane to the sphere or cylinder or hat, right? Isaac has a hat, I think. Isaac's hat. Instead of saying that, they use parametrization to describe how this hat looks like or whatever the shape is. And you should not be afraid to see something new. What is u and v? That's how they describe some new shape. And then all the steps are the same. Differentiate, plug in the point to find slopes. Those two vectors will create normal. That is taking us to the exam 2. Normal was found through cross product. That's the long process here. That's the longest process. Plug the point to find the point. Finally, build the equation. Done. So technically speaking, there's still 4 steps, but they're becoming longer and longer because we're working in 3-dimensional spaces. What do you think about that? So those will be our final exam questions, as you can see. It's nice when we gave you parametrization, but if we don't give you, guess what you should do? You should create it yourself, like we did before. So let's do one more example and move to parametrization. And then you tell me if you're stuck, we can do some homework examples on Wednesday. I will also hold extra office hours on Friday morning, so you should come if you want to. One more example. What if I don't give you the parametrization, and this time I will say, okay, it's not Isaac's hat anymore. I will say find the tangent plane to the sphere. Nope. PHR. To the sphere. X squared plus y squared plus z squared equals 4 at 1, 1, 1, and square root of 2. Like so. So, bless you. Oh yeah, I always don't forget to tell students, bless you, last 2 weeks, do not get sick. Don't go to any party, order grocery stores, close your doors, close the windows, don't talk to people. I'm not joking, actually, when I had final exams, I would isolate myself, flu, cold, all those things are happening all the time. You get sick, again, that's the worst moment of the semester to get sick. Try your best. Have lots of garlic and onion in your room so nobody can enter. You know, vampires protected. Don't get sick. Well, if you are the vampire, then you're probably fine, I guess. I don't know. You want to live forever in college, in finals exam forever? That would be interesting. You can be a vampire only if you're handsome. You know the Twilight, right? All the vampires are handsome people. So apparently, that's the requirement. So, the plane looks like that. At 1 and square root of 2. Did I accidentally put, why did I put brackets here? That's a point. So there's no parametrization. Let's parameterize, and that's what your homework is right now as well. Parametrization, step 1. If I did not give you parametrization, then you do it. Parameterize S. We know spherical coordinates. Let's review very fast. We did it right before the exam. 3 spherical coordinates. I remember it's 2 cosine theta and 2 sine theta, but each is multiplied by sine phi and sine phi. Z is, okay, we need to figure out why 2, but it's fine. Cosine phi, checking. Yeah, see, I remember. Why it's 2? Who knows?
Because the radius is 2 squared.
Radius is 2 squared, exactly, thank you. So it was given, and then there's no shift. So as you can see, x plus y plus z, x squared plus y squared plus z squared. So there's no shift in the point. So parametrization will be from here. I'll put it in blue. R depends on theta and phi. It makes sense that R radius is fixed. The capital R is fixed. It's 2. So that's actually not the parameter. Parameter is whatever is changing. And there's 2 things changing. Rotation around, that's my theta, and rotation up and down, that is my phi. So it makes sense actually to describe it in an easier way, or one line way, which is put your x, y, and z in order. It's going to be your x, y, and z. So 2 cosine theta sine phi. I'm just rewriting. No, not enough space. In terms of theta and phi, 2 cosine theta sine phi, 2 sine theta sine phi, 2 cosine phi. Close it. Where you describe each parameter, and that is a parametrization. So as you can see, it's not too bad. Especially if the shapes are very typical, from 0 to 2 pi, from 0 to pi. That is a parametrization. Like so. Find theta and phi. Yeah, we kind of don't know the point, right? So last time we had u was 1 and v was 2. Now the point is given. That is going to be step 2. Step 2 will be, we need to find what is my theta and phi. Well, we have x, y, and z. X, y, and z is the point. I would say the point. Yeah, not the vector. The point is given 1, 1, and square root of 2. So we set it equal to this huge equation. So let me just copy it. And we'll have to solve it. There are 2 unknowns and 3 equations, so definitely it has a solution. That's actually too much information to solve it. Like so. So now you can set each piece equal to each other and solve. That is how we're going to find a point in terms of theta and phi. So we have 2 cosine. I would always start with the last one. You don't deal with the first 2, it's just too complicated. The last one is the best one. 2 cosine phi is square root of 2, because it's the easiest one. Immediately it gives us cosine phi is square root of 2 over 2. Phi, which is restricted from 0 to pi, is what? Pi over 4, exactly. So that we found phi right away. Right? Good job. Yeah, someone has remembered. And now there's a trick. Let's divide the second equation by the first one to get rid of the repeated variable. This is the repeated variable, this one and this one. Since phi kind of is not 0, we can do that. Why not? So let's divide divide. That's a popular trick. I remember that, also learning this. Sine theta and sine phi over 2 cosine theta and sine phi. Then what will be on the right hand side if I divide second over the first one? That's true. But I wanted to make it to be 1 over 1, right? So this piece divided 1 over 1 from the point. So we know. From here, let's start solving. Cancel, 2 cancels out, and you're right, it is tangent. So tangent of theta is 1. Theta comes from here. Theta is restricted from 0 to 2 pi, and the angle is pi over 4 again. So now we have, just like in the previous example, u and v were given. Here, u and v are theta and phi, and now we found them. So point is phi, theta goes first, theta and phi, which is pi over 4 and pi over 4. Nice. And now we repeat all the steps we had before. So the difference between previous examples, all of this time we just spent, we were looking for this information. Now we're going to differentiate, cross product, normal vector, and building the equation of the line. So I will just move a little bit faster because after this step, divide. Step 3, let's do 2 prime. Divide was 2 prime. Step 3, same as in previous problem. So we will differentiate your r with respect to each variable. R with respect to u now is r with respect to theta. R with respect to v is r with respect to phi. Carefully differentiate. Derivative, it's not going to be a product rule, a quotient rule. That's a nice part of this. Here it is in the box. Derivative of the first component with respect to phi, it's cosine theta. Cosine theta gives you minus sine theta. Everything is copied. So you have minus 2 sine theta. Sine phi stays because it's just a constant, comma. Second one, repeat the same thing. It's going to be 2 cosine theta sine phi. And the last one has no theta in it, so it's 0. Done. Plug in. It's nice to plug in right away. Usually people do a bar like we did before. And you plug in. Theta is pi over 4 and phi is pi over 4. In the book, actually, it's very interesting. Sometimes notation is comma in a list. Sometimes it's a column like so. Plug in, and you get minus 1, 1, and 0. This is your R1, the derivative with respect to theta, the first tangent vector. Yes? Yeah?
Couldn't theta also be 5 pi over 4? Because tangent of 5 pi over 4 is also 1, right?
5 pi over 4? Oh, 5 pi over 4. We restrict...
That's still 0 to 2 pi.
Yeah, it's fine. But usually, yeah, we just choose the easy one. Good question. 5 pi over 4.
Would that mean there are two like possibilities?
Yeah. Parametrization is not unique. That's a good question. Point is unique though. So point should come out of this point. Oh, I know how to choose. You plot it. Remember we did it in calculus 2 at the very end. If you have several options with probably here and here, you plot it literally on x and y and z, right? X and y and z, and see where it goes. If it goes up to the first quadrant, which is now it's not a quadrant, it's the whole thing, then you know which one to choose. Yeah, good question. Does it make sense? When you actually plot this point, it tells you which angle to choose. He's saying there are several angles that can give you tangent equals 1. How do we know which one to choose? That's how you plot it and see which one to choose. So on the 2-dimensional, it should be the first quadrant. That's why I chose pi over 4, right? Yeah.
Yeah, that makes sense.
Yeah, also just to remember, that's how we did. Second one, repeat the whole thing, plug in. Theta is pi over 4 and phi is pi over 4. You differentiate and you get 1 and minus square root of 2. You create a normal vector. Step 4. Just like we did before, normal vector is a cross product of RU times RV, but in this case it's R theta times R phi. Cross product comes from the determinant I, J, K, minus 1 and 1, 0. We just found this. 1, 1 and the minus square root of 2. Carefully calculate this. Minus square root of 2 and minus square root of 2 and minus 2. Find the point. Because we found theta and square and phi as square root of 2, pi over 4 and pi over 4, but we never plugged it in. So you plug it into the original R. Let's plug in pi over 4 and pi over 4 into the original. We always had this before in calculus 1 as well. That gives us a vector 1, 1 and square root of, not a vector, I keep saying vector. It's a point, a point. And finally you build the equation. The equation of a normal line, the equation of a tangent line with the given point, and the normal vector we found is normal goes outside, minus square root of 2, x minus shift 1, minus square root of 2, y minus shift 1, minus 2, z minus shift square root of 2 equals to 0. And it is the equation of a tangent line to the surface which we had to parameterize ourselves. From there we found theta and phi, and then everything becomes very standard. Differentiation, plug in to find a point, find a normal, build it. So it looks like so. The picture, the sphere, radius 2, point is given, find the tangent to that point, to this sphere. What do you think about this? It's lots of steps. The last chapters accumulate all the knowledge we had before, right from the beginning of the definition of the vectors. So, of course, it will be a lot of steps, and just keep those in mind and don't freak out too much. So, let's figure out something pretty cool, which takes us to a new chapter. Questions? Last moment questions? Yes?
How do you know the order to do the cross product in?
Oh. If we switch the order, usually the order starts how you choose parameter. If you choose theta to be first and then phi, then the first derivative with respect to theta and then phi, that makes the order over here. That will matter. If you choose the other way around, it will switch, and it will switch these two rows. Yeah.
Would be the same answer.
Should be, yeah. Should be the same answer. You can switch the rows. The properties of matrices that tells you that you can switch the rows, and determinant should stay the same as I remember. So usually the order is described by the choice of the parameters. For you to know, that's a very smart question. For you to know this order is very random. You can choose to be phi and theta. Of course, internationally there's some kind of agreement that x goes first, y and z goes after. Theta goes first, phi goes after. And then I, j, k, it's an international kind of agreement of the order. But to be honest, you can always switch back. And then even this point will have different, so these two will have different order, and the point will have a different order. Yeah. It starts from parameterization, yeah. Good question.